Okay, so we're talking about the one postulate and three theorems we learned that about parallel lines cut by transversal, and I asked you to think about it with this diagram. So if we look at this one, it's not doing what I want it to do. So the first one is the corresponding angles postulate, which says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Let's go ahead and mark those corresponding angles on this picture. That's not awesome color choice. 2 and 6. 1 and 5. 3 and 7. And 4 and 8. So those are the pairs and those are the angles that would be congruent if we know our line segments are parallel. Now the converse says the reverse of that. So it says that if two coplanar lines are cut by a transversal, so we have to start with the picture, otherwise we don't have the angle pairs, and a pair of corresponding angles is congruent. So if we have this picture, and let's go ahead and remove this piece where we know they're parallel. If we have this picture and we also know that these two angles, 2 and 6, are congruent, then we can prove that L is parallel to M. And that's what the converse says. And so there's one for each. This is, of course, the postulate. And you should take a minute to write that down. So go ahead and pause the video now and write all that stuff down. Then we can, of course, do some practice problems where we can set different things up equal to each other and prove it or whatnot. But then there's the parallel postulate. So the parallel postulate says that through a point P, not on line L, there's exactly one line parallel to L. We used this in algebra last year when we were writing equations of parallel lines. So here it is. It's an annoying postulate. It causes us all sorts of trouble. So the converse of the corresponding angles is used to construct parallel lines, and this parallel postulate lets us do that, and we can do a construction. It's not a big deal. Again, this is the foundation of the geometry we do this year. And again, go ahead and pause it and write everything down. And then, of course, I went the wrong direction. Okay. And we'll take a minute to come back to this one. We have the alternate interior angles theorem. So again, if we know that the two parallel lines are cut by a transversal, then the alternate interior angles are congruent. In this picture, 4 and 6, and 3 and 5. And the converse says that if you have two coplanar lines cut by a transversal, and you know those line segment angles are equal, one of those pairs is equal, then you can conclude lines are parallel. Again, pause it, write everything you see down, draw the picture, super fun. Then we have the alternate exterior angles theorem, same thing, and again, we'll just mark our alternate exterior angles 1 and 7, and then 2 and 8, and again, you're going to want to pause it, write everything down, mark the same things. Converse says if two coplanar lines are cut by a transversal and a pair of alternate exterior angles is congruent, then the lines are parallel, and again, this is quite boring because we're just writing down words. And we have our final theorem, the same side interior angles theorem, which does not say, it's the only one that doesn't say congruent. So it says that if 4 and 5 are not the same, but add up to 180, then the line segments are parallel. So this one, we'd want to add a piece of, so the measure of angle 4 is plus the measure of angle 5 equals 180. If that happens and we have lines cut by a transversal, then the lines are parallel. So again, take a moment, pause it, write everything down. These are our three theorems and one postulate.